Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, I will introduce myself. My name is Kamali Kurniasari with name 2024 32005. I am an undergraduate student of Information System at PLN Institute of Technology. Okay, so in this video, I will explain my machine learning practicum project entitled or about Gaussian naive Bayes. So in this practicum, I used a diabetes dataset obtained from Kaggle, and the dataset contains several health attributes such as pregnancies, glucose level, blood pressure, insulin, BMI, age, and diabetes pedigree function. The purpose of this project is to classify whether a patient has diabetes or not using the Gaussian naive Bayes algorithm. For this project, I used Python programming language in Jupyter Notebook with several libraries such as Pandas, NumPy, Matplotlib, Seaborn, and scikit-learn. But before I explain the project, I will share my screen first. Okay. Okay. Okay, so first one in here, I imported all the required libraries for this project, where the pandas is used for reading and processing the dataset. NumPy in here is used for numerical operation, and Matplotlib and Seaborn in here are used for visualization, and scikit-learn um, in here is used for machine learning implementation such as data splitting, model creation, normalization, and evaluation. This step is important because every library has a different role that supports the data analysis process. And after I import the library in here, we just reading the data set. In here, I loaded the data set using the read underscore CSV function from Pandas. And after that, I displayed the first 5 rows of the dataset using head in here. And this step helps make sure that the dataset in here has been successfully loaded into a Jupyter Notebook. And the dataset contains several columns related to patient health conditions, while the outcome columns becomes the target variable. In here, there is the outcome. Value 0, it means that the patient doesn't have diabetes, and value 1 is means that the patient has diabetes. And after that, we just reading the data set. I check the data set information using info and shape in here. From the result in here, the data set is contains 768 rows and 9 columns. All columns in here are used numerical data types, which means the data set is suitable for Gaussian naive Bayes. And this step is useful to understand the structure of the data set before continuing to pre-processing and machine learning. Okay. And then in here, I just check whether the dataset had missing values using isnull.sum. And missing values are empty or null data that can affect model performance. So based on the output, there were no missing values found in the dataset, so that the data could be processed directly without additional cleaning. Okay, in here we just enter the exploratory data analysis. The first one is outcome distribution. Um, in here, we just visualization, and I created was a plot for the outcome column. This graph shows the number of patients with diabetes and without diabetes in here. In here, with no diabetes, and in here with diabetes. From the visualization in here, we can see the number of non-diabetes patient is larger than diabetes patient. And this steps is very helps us to understand the class distribution in the dataset. Next, I created a heat map correlation graph using Seaborn. And the heat map shows the relationship between variables in dataset. And from the result before, glucose and BMI have relatively strong correlation with the outcome column. And this means these features are important in predicting diabetes. And the heat map also helps us understand the relationship between features more clearly. And then the third one is I created a histogram distribution for the glucose feature. This visualization shows how glucose values are distributed among patients. Since glucose level is one of the main indicators of diabetes, this graph is useful for understanding the overall pattern of the data. Okay, after ADA in here, I just separated the data into features and target variables. For variable X contains all columns except the outcome, while variable Y contains only the outcome column. The separation is important because the machine learning model uses the features to predict the target variable. And then next, I just normalized the data using standard scalar. Normalization is necessary because every feature has a different value range. For example, glucose values can reach hundreds, while diabetes pedigree values are much smaller. Normalization help balance all features so that the model can work more optimally. And after normalization, I divided the dataset into training data and um, testing data using train test split. And in this project, I just used 80% for training data and 20% for testing data. And I also used random state equals 0. So the data split remains consistent every time the program runs. The training data in here is used to train the model, and for the testing data is used to evaluate the model and on unseen data. Okay, after we divided the training and testing data, in here I just created the machine learning model using Gaussian naive Bayes from scikit-learn. I used Gaussian naive Bayes because the dataset contains numerical continuous features, and this algorithm works based on probability and assumes that each feature is independent from the others. And next, I just trained the model using the fit in here. Yeah, in here I just train the model using the fit function with the training data. And after the training process was complete, I performed prediction on both training and data and testing data using the predict function in here. And these prediction results were later used for evaluating model performance. And then I just calculated the training accuracy and testing accuracy using accuracy underscore score. Training accuracy shows how Well, the model learned the training data, while testing accuracy shows how well the model predicts new unseen data. And from the result in here, the model achieved good accuracy values, which indicates that the Gaussian naive Bayes algorithm can classify diabetes and quiet effectively. And after we just calculated the accuracy, we I displayed the classification report in here. The classification report contains um, precision, there's precision and recall, and then F1 score, and the last is support. Precision in here shows how accurate the model is when predicting positive classes, and recall in here shows how many actual positive cases are successfully identified by the model. For F1 score is the balance between precision and recall, and the support shows the number of data samples in each class. This report helps evaluate model performance in more detail compared to accuracy alone. And after classification report, I created confusion metrics for both training and testing data. And here, the confusion matrix visualizes prediction result into 4 categories. In here, there is true positive, true negative, false, uh, false positive, and false negative. This visualization helps identify prediction errors mode by the model more clearly. And I also used heat map so that the confusion matrix becomes easier to read and understand in here. Okay, and the last one is I created a bar chart to compare training accuracy and testing accuracy in here. From the graph, the difference between training and testing accuracy is not too large, which means the model performs quite well and doesn't significantly overfit. This visualization helps us understand model performance more clearly too. Okay, so based on the overall results, the Gaussian naive Bayes algorithm can classify diabetes and quiet effectively. And then, even though naive Bayes using a relatively simple uh, probabilistic approach, the model still provides good performance for numerical classification problems like this dataset. Through this practicum, I learned the complete machine learning workflow starting from pre-processing, exploratory data analysis or EDA, model training, evaluation, and visualization. I also learned how machine learning can apply to health data analysis for predicting diabetes status. Maybe just enough for my explanation. Thank you very much for your kind attention. And I'm very apologize if there are any mistakes on my explanation before. And the last I say, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.